Can I pinpoint you and ask a simple question? If you could name one difficult thing in software engineering, what would be?
People.
Sorry for pinpointing you. Yeah, just say anything.
Getting the requirements right.
Oh, nice. That's already see that you probably nailing it, because to me, it's not even there. It's communication. Let me tell you how I got here. So I was there talking with my team, and they said, we support people to get out to GopherCon. And I was like, oh yeah, I never went to GopherCon. That sounds amazing. Count me in. And they said, Adam, we do our best to get you out there. And I was like, that sounds a bit over dramatic, but okay. I like their passion. And then around 2 weeks afterwards, my team lead said, hey Adam, it's about time that you submit your presentation, summary and such. And I was like, a what? And he was like, oh, come on, it's good. You just need to practice a bit, leave out your comfort zone. And I was like, dude, I just bought an IKEA chair for that. Anyway, I'm glad that I'm standing here, because the topic I bought here is really dear to me. So let's get cracking. The secret agile weapon, microservices. This presentation is intended for the general audience, so there won't be code examples. First of all, let me introduce myself. I am Adam Luzsi, your friendly neighborhood software engineer. Programming is my bread and butter, and that's my work, my hobby, and the primary root cause of my constant sleep deprivation. Before jumping into the main content, allow me to share my vision with you. I have a dream. It's about making people aware about what is the fundamental goal that software design meant to achieve. And sure, we often say that software design and architecture is an ever-changing thing and like that, but I want the people to know what is the reason behind this. To avoid doing dogma out of habit, to know the whys. So I set myself on a path to change this by sharing my experience through mentoring and also through teaching test-driven techniques, test-driven design techniques. As from my hobo appearance, you can guess, I'm a long-term employed. I work for SaltPay. But enough about me. Microservices. Who is familiar with the concept? Please raise your hand. I'm glad. For those who aren't familiar with the concept, the idea is that we focus on making individual services, and we build our product or system through their composition. My parents often told me that first impression is the most lasting one. So allow me a bit detour to share my first impression about microservice architecture. I can remember around 10-ish years ago, this was the new kid on the block, and there was a massive hype around it. Back then, I often went to meetups to get some free pizza and beer, and for the talks, of course. And I kept meeting their software engineers who talked about microservice architecture like a missionary. They spread the belief that you get salvation through using microservice architecture. Everything will scale, while also being instantly modular and reusable. I'm not going to lie, I was all in for the sales pitch. I just missed the explanation about what is the underlying issue it meant to solve. It felt more like these people passed the hype, not the knowledge. At that time, I didn't bother myself too much with it. I tried to keep everything as pragmatic as possible, because I was placed in a project where I had to use a programming language that I never seen before, while I was learning from a colleague that was the grumpiest person I have ever met in my life. We are close friends now. And on top of that, The architect decided to change the design on a weekly basis with such reasons. Let's use this because it scares. So yeah, that's how I first met and started to work with microservice architecture. I didn't question things. I just wanted to survive. Knowledge I gained during my junior years formed the very foundation of my software engineering knowledge. I'm still in the process of unlearning them. I mention this because knowledge we gain under such stressful situations can introduce cognitive bias. Because we lack the time to revisit and challenge these beliefs, and especially if new goals are constantly keeping our attention. And as we continue to use these experiences, noticing problems with it becomes even more difficult, much more than with fresh observations. Our fast thinking just kicks in, and we often take knowledge like that as the truth. This applies to design decisions and patterns we use from the get-go when we start something new. That's why I love mentoring. Good mentees storm me with their questions, and thus they forced me to re-evaluate my own experience. When I was revisiting my experience with software design, I asked others to share their view on software design. Of course, I got very diverse replies. Most of them explained design through their conventions, such as code structuring, design patterns, directory layout, and so on. But I saw one recurring pattern across all the replies shared with me. The practice, the convention, the patterns we use, they all try to align to help us battle with a universally constant constraint, to make the code for us. Now bear with me why this sounds simple. There is more than what meets the eye here. One of my favorite software engineers, Martin Fowler, said, "Any fool can write a code that a computer can understand. Good programmers write a code that humans can understand." I really like this thought. I have to admit, I wrote most of my code during my early careers for the computer to make it faster, smarter, and so on. Please raise your hand if you happen to did something similar. Oh, thank God I'm not alone. Hey, if anyone is here anyone is here maintaining any of my old code, I'm truly sorry. Because I was missing the point. Software design fundamentally about two main topics. The first is to solve a contextual related problem, such as budget constraints for your company or to scale your application to meet the demand. And the second is to not lose the focus, making the code for humans, to battle the natural limitations of the human mind. To make it easier to grasp the limitation, let me present you the Pomodoro timer technique. Who is familiar with Pomodoro timer technique? Right, it's not everyone, so for those who aren't, basically it expects you to divide your workflow into 25-minute sessions with 5 minutes breaks. Wait, hold up, Adam. So how this helps us understand software design, system complexity, and how on earth this relates to microservice architecture? I promise, this is the last detour. So the session serves as a form of restriction. Imagine you're in the zone. Finally, you have every necessary information in your head. And suddenly, time is up. I hated this feeling. I thought that Pomodoro timer is just not for me, or not even for software engineers. But eventually it struck me. The more time I need to get into the zone, the bigger the mental model I need for my task. And this is what I failed to understand initially. The time to enter the zone is a metric that shows me the hidden complexity I was dealing with. Pomodoro Technique was forcing me to reduce the size of my task consciously, to organize my code in a way that requires less knowledge to get started, to shift my responsibility about what I need to know into tests that will remember that for me, to reduce the time and thinking cost that requires for my task. Which brings us back to the main topic, software design, because this is one of the most important high-level goals it meant to achieve for us. If the code I need to work doesn't follow software design principles, they are likely not optimized for the limitation of the human brain. Therefore, I need more time before I reach the zone, or to even feel brave enough to touch a less-known code base. If software design what helps developers to optimize the code for human needs, then software architecture provides a set of conventions at a high level that makes us more pragmatic to reach the goal of software design, while also focusing on solving a contextual problem. I think we are okay now with clarifying the meaning behind architecture from the microservice architecture name. Let's check the microservice part. What is the fundamental issue that microservice meant to solve? We can easily guess that it will be something related with a human factor. To figure this out easily, I'm going to compare microservice architecture to monolithic architecture. Most developers often has a strong bias against monolithic architecture. Their first experience usually starts with a monolithic project, and they often make their first mistakes in them. If these learning mistakes accumulate over the year, we can end up with code base that is really difficult to maintain. And thus we often hear bad code associated with monoliths. If this pair with bad or non-existing testing practices, then the system will reach a level of solidity where it will be resilient against all change attempts. We often call such system as a legacy, or as a friend of mine say, big ball of mud. In practice, this tech debt densification can occur regardless if the system aligns to monolithic or microservice architecture. If we look over this and do a bit of mind game together, where we make an application in both architecture with engineers who follow well-defined design principles, which assumes that both solution is stateless and shares state only through attached external resources, then it's likely that both solutions will have modularity, scalability, and even integration, as with feature flags you can replace old solutions without leaving the process runtime. But solving distributed development in a monolithic architecture will encounter some serious constraints. Distributed development enables small teams to develop, deploy, and scale their own code independently. I would say, now we're talking. This is one of the key points of microservice architecture, because if everybody is in the same boat, but with different destination in their mind, it's just doomed to happen that we step on each other's toe. Story time. Many years ago, I was working on this magnificent legacy system with a couple of million lines of codes in it. And our company had many small independent team that was working with this piece of living history. But even mentioning the possibility to upgrade the application's language version was enough to instantly make 100+ dev feel distressed. Or if someone merged a broken code and went on a quick smoke break, it was stealing time from everyone until the broken code was reverted. Frankly speaking, everybody just wanted to isolate themselves into their very own corner to avoid frictions. And this desire to own this corner that we can look through and maintain is what we often call code ownership. We like to keep things separate. That's their stuff. I don't want to touch it. And that's my stuff. Please don't touch it. For example, we often call legacy code as some source code inherited from someone else. Thus, we have negative feelings with code that we didn't make. And this brings us back to the microservice architecture again. What we gain is the ability to split code ownership within the system. This allows us to choose our programming language, packages, coding, testing style, and so on to our liking. In a monolithic architecture, the lack of consistency would be a huge pain point. But in microservice architecture, this is often fine to a certain degree, because you will be less likely to ever maintain any of that code that was made by another team. And here comes an important aspect from the HR point of view. You can scale your company's side without being heavily restricted. You don't need to find people who knows how to write in an ancient templating language just for the sake of making new product. You can hire people who has the knowledge that allows you to deliver the product you need. And this makes microservice architecture a perfect vacuum for scaling the human resources of your company. This also means that microservice architecture is a tool to solve an organization management-related issue. But a tool is, after all, just a tool. It can be just as good as how it's being used. Using microservice architecture without understanding the fundamental goal of software design will have significant price. To pick an example, let's talk about code mistakes. In a monolithic architecture, this is relatively straightforward. You're in a single code. Many editors support refactoring across the many package. So refactoring the code as a single individual or debug is possible, even if sometimes a bit tricky. But when your code base is split across several owners, a simple coding mistake correction can turn into a battle of change requests across various backlogs of different teams. And the feedback loop from ours can increase up to iteration cycles, with extra effort to support backward compatibility with each modification. In other words, the forgiving environment will be no more. The effort to fix mistakes at a system-wide level will increase, and so does the challenge to deliver these improvements. Joseph Tainter wrote a book about the collapse of complex societies. His goal was to answer the question about why did such mighty societies collapse. In his analysis, Tainter found that the primary enemy of these societies to be complexity. As the civilization and most companies grow, they add more and more complexity, more hierarchy, more bureaucracy. Until a certain point, this brings value, enable members to achieve more in cooperation. But after it goes over a certain threshold, adding complexity will cost more than how beneficial it was before. The system eventually becomes inhuman, alien, something an individual cannot comprehend with their mind alone. Too corporate, if you may. Conway's law say that an organization, such as a company, which goal is to design a system, will produce a design whose structure is a copy of the organization's communication structure. Basically, if we nourish a mindset at a company level that each team is an isolated unit, then the product, the infrastructure, will reflect this communication pattern. And you, as an individual, you end up in a situation where you're no longer able to understand and comprehend the system as a whole. The problem is, it is rare that a microservice is truly isolated. Just as we said, system consists from microservices. So a microservice is just part of a bigger system. You will be forced to find people to help you out on a shared staging environment, and it might turn out that corners were cut here and there, so it's not working and behaving exactly like in production, but you are reassured, but in production, it will work as expected. So basically, dev prod parity won't be true anymore. You started from the comfy situation where you could hack and learn about the system in the safety of your recreatable environment. And now you gently suggested that if you want to see the system's true behavior, go and learn on a shared environment as long as you don't harm it. And you quickly realize that the least risky move is just add another new service to the company system, make new boxes on diagrams to solve requirements while avoiding touching other boxes. And eventually, you come to the conclusion there is no chance that anyone can understand this system. And no, and who knows? Maybe your business domain is not even a rocket science, just something a junior do as a hobby project during the weekend. Okay, so what now? What can you take from here and do to make a change? I hear way many times from Go developers that you need to go with a simple, easy solution. But a simple solution is not equal with achieving simplicity. I want you to challenge that. Adding complexities is easy, simple. Subtraction is what hard. Be the change who stands for simplicity and willing to face the neglected tech debt. Think about the Pomodoro timer. When you want to work with the system as a whole, and you can't get into the zone within a reasonable time, you have a problem. Your company has a problem. Try to focus on the goal of the concepts. Monolith, microservice. Don't let your brain focus on the obvious differences. Think about what you can do to make them similar. So only the actual difference remains, which is the freedom in code ownership. Make your service easy to test by those who depend on you, just like you make it easy to test and use a package for yourself. Think about the service as a module of a bigger system, not as a small, isolated product. Fight for DevProd parity. DevProd parity is not just about running your microservice on your machine as you do on your production. It's about enablement for engineers to communicate through their code, to allow them to play with the system as a whole in their safe corner that represents reality as close as possible. Continuous integration is not just for deployment, but for wordless communication and collaboration, similar to what trunk-based development are. There are solutions already out that can make that happen. And to run clusters of microservices like a single system on your computer. But it won't happen unless we consciously break down those silo walls. All I'm saying, be the change and make that system manageable by humans. Because writing code for humans doesn't stop with functions and structures. We are building a system together, and if we build walls and silos ourselves today, our system will reflect this clearly by tomorrow. We need to make that change happen today, and for that, your help is needed. To make the code, to make the system, to make the product for ourselves. I'm not kidding myself. At best, 20% is the max that most people remember at the presentation. But if I was able to plan the idea that working in a microservice architecture setup doesn't mean that you focus communication on meetings, but instead you make that happen to work without wordless communication as well, then I'm already happy with the outcome. Thank you so much for coming today. This was my very first presentation at a conference, thanks to the mixed communication. And I'm really happy that I was able to talk with you. I hope you like the topic.